Okay, so I will check out your Flappy Bird games today. Here in a little bit. I then on Wednesday I will check out your runner game with the dinosaur. Today we're going to talk about some more refined things in Unity, such as 2D movement, animation, which is to say uh, animation beyond um, just the flapping of the bird's wings. Now, that being said, as you will notice when we watch the 2D animation video here in a minute, um, once you've kind of mastered it in the Flappy Bird game and in the dinosaur game, you pretty well understand how animation works in Unity. But he does have a video dedicated just to it because it's not just a singular looping animation the way that it is in the first two games. What he's going to demonstrate is how to do 2D animation based on states. So if I'm crouching, it plays this animation. If I'm jumping, it plays this animation, and so on and so forth. Okay. So we're going to watch that, the 2D movement, 2D animation, and then 2D pathfinding, which is a scenario where you have an enemy, and the enemy will, when you get within a certain range of it, it will attempt to chase you. If it's flying up over here and you get to a certain place, it'll come down and try to chase you like off the screen and that kind of thing. Next time, we'll talk about top-down 2D animation, so like a Legend of Zelda style game. As we go on, we'll talk about so like next week and that sort of thing, and if we have time, possibly a little bit this week. We'll talk about how to do maybe experience or chests that you can open and different things like that. For anybody that's had Game Dev 2, you're familiar with the concepts of how to do that sort of thing, like within RPG Maker, but we'll learn how to do that sort of thing in Unity as well. My goal, and the way that I've got this all set up, the course rotation and everything, is that you will be able to create in this class for your final project, if you so choose to make a game of whatever genre you want. You'll be able to make, if you want to make a first-person shooter, they have a pre-build that you could modify very heavily to make your own. You can use the things that from the videos that we've been watching and that we are watching to make your own endless runner or your own platformer or your own RPG or your own, what have you. So because we were going to watch a video that would explain how to do like a Metroid style game. So if you want to do like a Super Metroid style game, which is kind of a platformer shooter kind of game, sort of kind of RPG also. So anyway, without further ado, let's check out this video, 2D movement in Unity. One final thing, this is the Brackeys guy. Did we watch one of his videos last time?
I think so, yeah.
Okay. Oh yeah, we watched the sound one. Yeah, the sound one. He is one of my absolute favorite tutorial guys on YouTube. Unfortunately, he has taken an indefinite hiatus from making new content as of about 6 months ago. So he hasn't made any new videos, and there's no guarantee that he will come back at all. But he left behind a wonderful repository of resources, nearly all of which, I would say basically all of which, are still relevant. There's a few that he's got that, like, the technology isn't around anymore and stuff like that. But for the most part, it's all still relevant. So, all right, let's check out 2D movement in Unity.
One of the most essential parts of creating a 2D game is of course player movement. And even though it's one of those basic mechanics that we often take for granted, creating a really good player controller can actually be quite challenging. In fact, it's something that even experienced programmers can spend weeks or even months of development time getting to feel just right. Of course, everything depends on what you want your character to do. Can he jump? Can he be controlled in air? Can he crouch? Can he wall run? Does he slide down ledges? What about animation? And so on. Now that might sound a bit overwhelming. But as always with game development, there are ways that we can cheat a little bit. If you're just starting out, I really recommend finding a good character controller online, simply because you don't want to be stuck doing movement when there are so many other aspects of game development that you should explore. Also, this video is sponsored by Skillshare. Skillshare is an online learning community with more than 21,000 classes on just a script that takes care of all of the more advanced physics calculations that go into making your character move. So by using one of these, we can focus on writing a much simpler script that will just tell the character controller what to do. For the purpose of this video, I've of course gone ahead and prepared a character controller that we can use as a base. But enough talking about it, let's give our player some moves. Yeah. So we're here in Unity, and I've gone ahead and set up a simple 2D scene using the Sunnyland asset from the Unity Asset Store. I'll of course have a link for that in the description. There's not much in here. There's currently just a player which has nothing on him other than a sprite renderer, as well as a main camera, of course some different tiles making up our level, and I've gone ahead and placed...
While I'm thinking of it, I forgot that the not forgot, I'm sorry. When you downloaded those, when you went to the character controller script, was there anything else there or just the character controller script?
Just a README.
Just a README? Okay. So I was, for some reason I was thinking that the project was downloadable, so that, which is to say you would have the, like the tile map already set up, okay? For now, just follow along with the creation of the scripts and things like that. It's going to throw you some errors saying like, hey, there's no game object like assigned to this thing or whatever. Just ignore those for now. The only difference is you won't be able to test anything, but we'll go over tile mapping maybe today if we need to. But we'll go there. So just try to follow along with the code as best you can.
Colliders on the platforms as well as the ground. And then we have a few background elements. So since we're going to be using a character controller to help us with our movement, we of course first have to get it into Unity. Mine is right here on the desktop. I'll of course have a link to where you can download the script as well as the entire project. So I'm just going to take this and drag it into Unity. And right away let's select our player and drag our script on there. If we have a look at the different variables that are in our script, we can see that we can adjust a bunch of different things that has to do with our character. First of all, we have the jump force. I'm just going to set this to a value of 700. We then have the crouch speed, which we can adjust using a slider here. And this is basically how much we want to slow down when crouching. I'm just going to set this to something like 0.4. And so we're going to be moving at 40% speed while we're crouching. We can also adjust how much we want to smooth out our movement. I'm just going to leave that as is. Whether or not we want to be able to control the character in air, which I definitely do want to. And then we have to define this what is ground variable. And this basically just allows us to choose what layers we want to act as a walkable surface for our character. I'm just going to set this to everything and then go back in and remove the player layer, because we don't want our player to be able to walk on top of himself. I'm also going to go to the top and change his layer to player. And then we have these 3 empty slots. The first 2 are what we call checks. And we use these to check whether or not we're currently standing on the ground so that we can determine whether or not we can jump. And if we're crouching, we want to know if there's a ceiling above our heads in order to determine if we can actually stand up again. And to make things simple, we're using these empty objects to determine where these locations are. So let's go in and create these objects. Let's right click on the player and let's hit create empty. And I'm going to switch to the move tool here by pressing W. And now we can see where the empty object is. I think this is pretty close to our ceiling check, but I'm just going to go ahead and move it up a tiny bit. Something around here. I'm then going to duplicate it by pressing Ctrl D and move this one down to the feet of our character. I'm going to rename this one to ground check and the other one to ceiling check, just to stay organized. We can then select our player and drag our ground check into the ground check slot, and the same thing for the ceiling check. The last variable here, the crouch disable collider, we'll talk about later. But our character controller is now set up and should work just fine. However, there are a few more components that are required in order to make our player work. The first one of these is of course a rigid body, because this will enable physics for our character. So let's hit add component and let's search for rigid body 2D. We can then open up this component, and the first thing that we want to do in here is probably bump up our gravity scale. In general, it feels nicer if your character has a larger gravity than other objects. It makes stuff like jumping feel more snappy. I'm gonna set mine to 3, but you can of course experiment. We also don't want our character to be able to rotate at all. We simply want him to move around the level, but always have him facing upwards. Because of this, we can go under constraints and freeze the rotation on the Z axis. And now he should stay the same at all times. Finally, we need to go in here and add a collider for our player, because right now if we play the game, we can see that he simply just falls down. but it can actually be a really good idea to use multiple colliders when you're working with a player. This can help smooth out collisions or make them feel more realistic. One fairly simple setup that I really like is using two colliders, a circle collider and a box collider. Let's start by creating the box collider. So we'll go in here and add a box collider 2D. Let's open it up and we should now be able to see it. However, the background makes it pretty hard to see. So I'm just going to go under my main camera and disable the background for a second. And now when we select the player, we can clearly see the green bounding box. I'm going to hit F to focus on our player. I'm then going to press Edit Collider. And we can now scale our collider to fit our player. One thing that I recommend is holding down Alt to scale on both axes. One of the reasons for this is that we don't want any offset on the X-axis, because since we are flipping the character, that's going to make the collider behave really weird. So I'm just going to bring this in, and I'm also going to bring it down on the Y. And finally, I actually want to completely remove this collider from the feed of our character. And that's because I found it works much better to use a circle collider here. So I'm going to stop editing this collider and add a circle collider as well. Circle collider 2D. Let's open this up as well. And we can see right now it isn't really positioned in a way that we would like. So we can of course go in and offset it on the Y here, as well as press Edit Collider and kind of bring it in. And I'm going to go ahead and move it up a tiny bit more. And if you slide on a value like this in the inspector while holding down Alt, you'll be able to fine tune much more neatly. Something like that looks pretty good. I'm actually going to adjust the radius to be just a tad larger and bring it up a tiny bit more. And finally, I'm going to take the box collider and bring it down a tiny bit and inwards a tiny bit. There we go. Let's stop editing the collider and we now have these two overlapping colliders. And you can already kind of see what the benefit of this is. Because say we want to move up a slope like this one, if we were only using a box collider, it would take the edge of this collider and kind of push it towards the slope. However, since we're using a much more rounded shape, our movement is going to feel much cleaner when moving up the slope. And that's actually another reason which has to do with crouching, but we'll see that later. So let's move our player back up, and if we now hit play, we can see that immediately our player falls to the ground and he's ready to start moving. So let's stop playing. Let's re-enable the background here. Let's select the player. I'm just gonna close all of these components and let's add our player movement script. Let's hit Add Component, search for Player Movement, select New Script, create an ad, and let's double click it to open it up in Visual Studio. And the script that we're going to be creating here is fairly simple. And the very first thing that we want to do is get a reference from our player movement to our character controller 2D, so that we can tell this script to move our character. To do that, at the very top of our script, we'll create a public character controller 2D variable, and we'll simply call it something like controller. If we then save this and go into Unity, we can see that we now get this empty slot called controller, where we can drag in our character controller script. And now every time we write controller in our movement script, it's referencing this particular script. So if we were to go in here and write controller.move, well, this would go ahead and move our character. But of course, we can't just tell it to move. We need to specify where we want to move, both in what direction and at what speed. So to do that, we need to get some input from the player. And every time we get input from the player, we use the input class. So I'm going to write input dot, and then we're going to use a function called getAxisRaw. And the axis that we want to get here is the horizontal axis. Now what this is basically a value between -1 and 1 that is going to change depending on the user input. If we press the left arrow key or the A key on our keyboard, this is going to be -1. If we press the right arrow key or the D key on our keyboard, this is going to be 1. And similarly, if you're using a controller and press the thumbstick all the way to the left, it's going to be -1. And to the right, of course, it's going to be 1. So this simply gives us a value that determines where we want to move on the horizontal axis. To kind of show you this happening, I'm just going to use a simple function called debug.log. And this will print out a message to the console. In other words, we can simply display our input here inside the editor. So if we just write out this piece of code here and save it and then hit play, we can see that in the console here we get a bunch of messages saying 0. However, if I then press my left arrow key, we can see that it says -1. And if I press my right arrow key, we can see that it says 1. So now we have a way of detecting input. I'm going to get rid of the debug.log here, and we could use this input to move our character right here. But it's not recommended to move a character inside of the update method. Instead, we want to use another function that is dedicated for physics. This function is called fixedUpdate, and it works in much the same way as update. However, instead of being called once every time the computer draws a frame on the screen, it's called a fixed amount of times per second, hence fixedUpdate. So let's just go ahead and create this function. I'm going to write void fixedUpdate. Let's open and close two parentheses and some curly brackets. And this is where we want to move our character. So in general, when it comes to movement, we can say that we use the update method to get input from our player, and we use the fixedUpdate method to apply that input to our character. We're not really using the start function here, so I'm just going to remove that. But we of course need to get this input from one function to the other. And to do that, we need a variable. So at the top here, I'm going to write float. And let's create a variable called something like horizontal move. And by default, we'll just set that to 0. Then inside of our update method, we can set horizontal move equal to the result of our input. And we'll close that off with a semicolon. Then when we want to actually move our character down here, we can write controller.move. And this of course takes in a float determining how much we want to move. And we want to move according to our horizontal move variable. And let's then close that off with a semicolon. However, our move function actually also takes in two other variables. The first one determines whether or not we should crouch, and the second one determines whether or not we should jump. Right now we'll just say no to both of these, so we'll write comma and then false, saying that we don't want to crouch, and comma false, saying that we don't want to jump. But we'll of course implement both of these in a sec. Also right now we're moving our character in the right direction, but we don't have any control over the speed. So let's just go to the top here and create another public float, and we'll call this one the run speed, and set it to something like 40 by default. Then when we get the input from our player, we'll go ahead and multiply that input with a run speed, so that if the player wants to move to the left, the horizontal move will be -40, and to the right will be 40. And the final thing that we need to do in order for this to work correctly is whenever we're telling our character to move, we actually need to multiply that movement speed with time.fixedDeltaTime. Now time.fixedDeltaTime is the amount of time that elapsed since the last time this function was called. In other words, multiplying with time.fixedDeltaTime is going to ensure that we move the same amount no matter how often this function is called. So that if this function is called 60 or 100 times per second, doesn't matter, our character speed is still going to be consistent across all systems and platforms. And now this should work, so let's go ahead and save this. And inside of Unity we can now see our run speed, which we can adjust here if we want to. Let's hit play, and we can now move our character back and forth inside of our level. You'll also notice that every time our player falls, he kind of shifts into the ground a little bit. To get rid of this, we can go under rigid body and change the collision detection from discrete to continuous. And this should make sure that he never kind of goes into the ground in any way. So now we're ready to make our character jump, and this is actually really easy compared to normal movement. All we have to do is check whether or not we press the jump key. So we'll write if input.get button down. So if we press down a certain button and the button that we want to check for is jump, well then we want to go ahead and jump. And of course, again, we want to jump inside of a fixed update function. So we have to kind of transfer this information down here. And again, the best way to do that is using a variable. So up here, we'll now create a Boolean, and a Boolean can of course only be true or false. And we'll call this one jump, and we'll set it to false by default. And then if we press the jump button, we're going to set jump to true. And then down in our fixed update, instead of saying always false, we never want to jump, we can now just pass in our jump variable. So that if we press this button and jump becomes true, we go ahead and tell the controller that we want to jump. And of course, right after that, we want jump to become false again, so that we don't keep on jumping forever. And if we save that and go into Unity and hit play, we should now be able to move around. And whenever we press space, voila, our character actually starts jumping. Super cool. Also, there's currently a quick problem that we need to fix. That is, whenever we try and jump and then move towards a platform, we can kind of get stuck on it. Of course, this is not something that we would like. We want to simply slide off and then fall down. To get rid of this issue is luckily super easy. All we need to do is create a physics material. To do that, we'll go to our project and hit create, and we'll then select physics material 2D. And we want to create a really slippery material so that we will simply slide off. So let's just call it slippery. And in here we can adjust two settings, the friction and the bounciness. We want the bounciness to remain at 0, and we'll also set the friction to 0 as well. Then if we select our player, we can take this slippery physics material and drag it into the material on our box collider. And now when we play the game, we can see that we slide right off platforms. We can still get stuck on the very corner of the circle. If this happens or not is going to depend on the way you've set up your colliders. In our case, we can simply go ahead and add the slippery material to there as well. And you can now see that we fall right off of platforms. And at this point, some of you might be wondering, well, we just wrote jump. Why does this jump variable correlate to space? And why does horizontal mean A and D and left and right? Well, this is actually something that we can configure visually, because inside of Unity, if we go to Edit, Project Settings, Input, we see the Input Manager. Here we have the horizontal axis. You can see it's called horizontal here, and we can see the different buttons here. There's the left and right arrow key, as well as the A and D key. So you can go in here and change it if you want to. And there's also one in here called jump, which currently has space as the positive button. If we wanted to jump on, say, W, we could simply write W here instead. In fact, let's try right-clicking on this jump entry here and hit duplicate array element. This is going to go ahead and create a new button configuration with the same settings. Let's rename this one to crouch, and instead of W, we'll use the S key. Of course, if people want to control the character using the arrow keys, we can set that up as well. We'll just create an alternative positive button. So here it will be up for jumping, and here it will be down for crouching. So now we've set up all of our input and we're ready to make our character crouch. And doing this is almost as simple as jumping. We go into our update, we write if input.get button down. And the button that we want to look for now is the crouch that we just created. And if this button is pressed, well, then we want to go ahead and crouch. So let's create a variable for that up here. It's also going to be a bool. Let's call it crouch, and let's set it to false by default. Then if we get the button down, we'll set crouch to true. And now down in our fixed update, instead of just passing in false, we'll put in our crouch variable. Of course, crouching doesn't work in the same way as jumping. We don't want to just quickly crouch and then stop. Instead, we want to stop crouching when we release the crouch button. In other words, we only want to crouch while holding down crouch. Luckily, we can also register whenever we release a button. To do this, let's go to the update function and let's write else if. So if we don't get a button down, we might get a button up. So we'll go input.get button up. And again, the button we're talking about here is the crouch button. And if we get a button up here, we'll set crouch to false. So now if we save this and go into Unity and hit play, we should actually be able to press down in order to crouch. However, you will really not see anything happen here. The reason why is that crouching is of course something that we display with an animation, and we don't have any animations on our character. However, we should see that if we move and then try and crouch and move, we move at a much slower pace. So it is indeed working. We can go between crouching and normal movement, and that works just fine. However, one thing that we also need to happen when crouching is of course the ability to duck under obstacles. For example, this platform here. If I currently select the player and we make sure that gizmos is enabled at the top here of our game view, let's open up our circle and box colliders. We can actually see them here. If we then try and move onto this platform, we can see that we're currently too tall to get under it. That's because of this box collider right here. What I've gone ahead and done is under the character controller 2D, I've added this crouch disable collider, so that if you set up your colliders in the same way that I have, we can simply take the box collider and drag it in there, and now whenever we crouch, the box collider is going to be disabled. And so we're only going to be using the circle collider. In fact, we can kind of see this happening. If I now press crouch, we can see that the box disappears. And if I try and crouch my way under the platform, it works. We can also see that if I try and stop crouching, so now I'm going to release the button, while under the platform it's not going to work. And that's because we've set up our ceiling check correctly. So it's registering that there's something above us, and so we don't want to be able to stand up until we get to a point here where there's no longer something above us, and so we'll stop crouching. That's super cool. Of course, this currently looks a bit silly since we don't have the crouch animation, but you can see that behind the scenes everything is working as it should. And that pretty much includes this first ever character controller. From here it's completely up to you to try and expand upon it and edit different settings to get the controller feeling the way that you would like it to. Of course, this character could really do with some animation, and animation is something that's really fun and simple to add, so if that's something that you guys want to see, definitely leave a comment down below. Yay!
Okay, so there's that. Now, I know that he has a video on tile mapping. Let me make sure that it is similar enough to what we are currently doing that we don't get completely thrown off here. Couple of little like pop quiz type questions or whatever. The F that he was putting at the end of some of those variables, what does that indicate?
That it's a float.
It's a float, very good. And did you notice that he, what's the word I'm looking for here? He duplicated the jump, right? And he did that by duplicating array element. And you may have noticed at the top, it indicated how big the array in question was, which is, how many of these different input elements can we hold, right? You may recall that he used that exact same concept whenever he was talking about sound. Remember that he said he just makes an array, and then he says, how big is this array? And then when you increase it by 1, you can add another sound to it, right? Which is pretty cool. So, okay, this one is actually top down. This is very frustrating. I thought he had one specifically for the Sunnyland, but let's watch this one. We probably should have started with this one, but let's watch this one first. Don't worry about following along. Just watch what he's doing. It's a fairly short video, and that way, when we break off to do the lab, you can actually put your tile map together and actually start doing some of this stuff. So if you were following along, outside of having the ability to test it, everything should be working. You should be able to drag and drop most everything in there as you went. Because at minimum you had the Fox sprite, right? So you should be able to do something with that. So let's check this out, and then we can move on.
Making your game art in tiles can be beneficial in a lot of ways. Because tiles are so modular, tile maps make it easy to create new levels and modify existing ones. Some good examples of games that utilize tile maps really well are of course classics like Mario and Pokemon, but also a lot of newer indie games like Spelunky and Stardew Valley take advantage of this art style. So in this video we'll have a look at how to use Unity's built-in tile map system. Also special thanks to Judeman, Beffio, Infinity PBR, Yorai Omer, and Hans Huftun for their support on Patreon. And with that, let's get started. So I just opened up Unity and currently we have nothing in here. But in order to start creating tile maps, we need to have a tile set. I went online and found this pretty cool tile set by Leonard Papin. As you can see, there are a bunch of different elements like rocks, dirt, grass, and water. And if we have a look at the ground tiles only, this is what we see. Of course, if you want to learn how to create your own tile sets, I have a tutorial on how to do that in Photoshop. But there are really a bunch of tiles in here, and there are even multiple tile sets for the different elements in the scene. So just to keep things simple for this tutorial, I've gone ahead and created a simpler version of the tile set, and I'll of course have a download link for that in the description. Let's take this file and import it into Unity. Let's click on it, and you can see here I've just selected the most basic ones. Now first we want to make sure the texture type is set to Sprite, 2D and UI. We'll then change the sprite mode from single to multiple because we have multiple sprites in here. We'll also change the pixels per unit to 32. The reason why is that the size of each tile in my tile map is 32 and I want one tile to be 1 unit big. Then because we're dealing with pixel art, we want to set the filter mode to point so it doesn't get blurred out. And we can also go down here and disable compression. Now if we apply these settings, we can open up the sprite editor, and here we want to define each individual tile. Luckily we don't have to do all this by hand, we can simply use the slice option up here, change from automatic to grid by cell size, because we know the size of each tile. That's of course 30.
Just want to mention real quick, if you have, and I believe the Sunnyland one is set up this way, if you have something where it's already split apart, you would leave type set to automatic, and then when you hit slice, whenever it sees that there's empty space, it draws the space around them automatically, which you may have noticed from the Flappy Bird tutorial, because that's and also from the sort of from the Chrome Dinosaur Runner. He had to do a little bit of modification on that one, but the Flappy Bird one works as soon as you hit slice.
32 by 32 units with no offset and no padding, and we can just go ahead and hit slice. And you can see it actually automatically registers all of our tiles. I definitely recommend you go through and see if everything is here. It certainly looks like it. With that, we can simply hit apply. And if we now close down our sprite editor, we can drop down this menu on our object, and here we have each individual tile as a sprite. So next, what we want to do is create a tile map. To do that, we go to the hierarchy, right click, go to the object and select tile map. And you can see it automatically creates this object called a grid. That's because all tile maps in Unity are rendered using a grid. So if we go to the scene view, we can see all of the grid lines. And of course, in each of these grid cells, we can now place tiles. If you've ever used the UI system, think of the grid just like a UI canvas. We can of course configure stuff like cell size and gap here, but in most cases, you probably just want to leave those be. Then we can expand this object, and under here we have our tile map. Now you can consider a tile map in Unity kind of like a layer. If we want multiple tiles on top of each other, we simply want to create multiple tile maps that we can draw onto. So this here is our first tile map layer. And so we can call it something like tilemap_base, just to let ourselves know what we want to paint onto here. And our tile map has two components, a tile map, which has configurations for the layer, and a tile map renderer, where you can configure stuff like what material to use. But we just want to leave all that by default, and instead we want to go window and bring up our tile palette. And this window is where we find all of our tile painting tools. We can go ahead and dog this to the right of our scene view, and maybe also give it a bit more space. Now as you can see, we have a bunch of different tools at the top. I'm going to show you what each of these do in a second. First we want to create a palette. And a palette is basically just a collection of tiles that you can choose from at any given time. So we want to go ahead and create a new palette, and we'll call this palette something like ground tiles. We just want it to be a rectangular grid, and we'll set the cell size to automatic, and now we can hit create. Now each palette is stored as an object in your project. So we could go and create a new folder here for all of our palettes. So I'm going to call this palettes, and we can go into the folder and hit select. And there we go, we now have an object in here called ground tiles. And you can also see it's selected right here. And in fact, it already tells you what to do. Drag tile, sprite, or sprite texture assets here in order to add them. So we can go to our tileset example and select each one of our sprites. And then simply drag them into our tile palette. Now Unity is going to generate a tile asset for each sprite. And since we have quite a few sprites, this means quite a few assets. So we probably want to go ahead and create a subfolder for this. We can call it tiles. And just to stay very organized, inside of this we'll create another folder called ground tiles. Let's hit select, and Unity will go through and generate all of the appropriate tile assets. And as soon as it's done, we should see all of them in our tile palette. You can also see on the left hand side here that if we go under our tiles folder and under ground tiles, all of our tile assets are here. And if we select one of them, we can either change the sprite that the tile asset uses, we can tint it a certain color, or mess with the collider type. But again, for now, we'll just leave all of those as is. And this is where we get to the most annoying part of using tiles using the current tile system. Because you'll notice that our tiles are laid out in a very chaotic way. So now we're actually ready to start painting using our tiles. To do this, I want to switch to the brush mode. The shortcut for this is of course B. And now we can start selecting tiles inside of our tile map. So say we want to select the corner right here, and then simply move our mouse into the scene view in order to start placing these. You can also select multiple tiles if you want to paint more at a time. So I'm going to start painting away on a tiny level. You'll notice if I switch to the game view now, I have these weird ugly lines. The reason why is we need to go to edit, project settings, and then quality. And in here we'll make sure to disable anti-aliasing. Anti-aliasing is meant to blur out edges in 3-dimensional graphics, but since we want very hard edges here in order to not see between the tile maps, we definitely want to have this disabled. So I've laid the foundation of my tile map here, and I want to move it kind of into the vicinity of my camera. So I'll take the selection tool, select the entire tile map, select the move tool, and then move it over. Some other tools that are handy is if you're using the brush tool and want to erase, we can simply hold down Shift in order to do that. We can also select the box tool. Using this, we can fill a rectangular part of the map. You can also select a tile by using the mark tool. I normally just use this by holding down Control and picking the tile that I would like to paint with. And finally, we can use the bucket tool, the one on the far right, by hitting G. And this will fill out holes using the selected tile. So I think I'm going to paint some water into my scene here. I'll see you in a second. And I'm also going to surround it with some grass. So now I'm satisfied with the base of my tile map. But I definitely want to overlay some objects on top of this. I especially want to add some rocky parts to my level. And you'll notice if I just select this and start painting on top of what I've already made, it looks really weird. And the reason why is that parts of these tile maps here are transparent. So we need the base layer to still be underneath. Luckily, we know that each tile map acts as a layer. So all we need to do is go into our grid, right click, go under 2D and create another tile map. And we can now rename it to tilemap_rock. We also want to make sure to set the order in layer for this to be greater so that all of the tiles that we paint appear on top. I'm just going to set it to 1. You can of course also put it on a separate sorting layer. Now we'll switch to our tile palette. We still want to paint using our ground tiles, but we want to change the active tile map from tile map base to tile map rock. And now if we switch to the brush tool, you can see that we can easily start painting away with these rock sprites. There we go. So finally I'll just take my camera here and zoom it out a tiny bit so we can see more of the level. And we've now created our first level using tile maps in Unity. Of course, there's still so much you can add to this, but as a base that looks awesome. So other than the stuff that Unity has currently built into the editor, they've also created a bunch of tile map features which aren't yet integrated. And you can actually find these on the Unity GitHub under 2D extras. I'll of course have a link for this in the description. If you want to use these yourself, simply hit clone or download and you can download it as a zip file and open.
Okay, so that's the basics of how to do tile maps. Okay, now obviously that top-down version would be more appropriate for like a Zelda-style game, but that should give you an idea of what it is that you're working with. Okay, so now that we've seen that, let's check out the 2D animation tutorial, and this will show how to implement the jumping animation as well as the crouching animation and the walking animation. Now the walking animation is exactly well, really, I guess all three of them are exactly like doing the Flappy Bird and the dinosaur running animation, but like I said earlier, the big major difference is that these animations are decided upon based on what button you're pressing and that sort of thing. So building upon the character controller thing that we did in the previous video. So let's check this out, and then we will be able to break and start working. So just to give you a heads up, just so you have a preview of what's going on. So Wednesday, your dinosaur runner will be due. Next Monday, the thing I will assign you today will be due, which is I just need you to make me a game in which you can move back and forth, jump and crouch. So if you don't want to dive too terribly deep into tile mapping, what I would recommend you do is get the Flappy Bird assets and just use the ground tile that already exists as your ground and just put a box collider on it, right? So that your character can stand on it. That's my recommendation. You don't have to go that route, but that would be the simple, quick, easy way to do it. So just wanted to throw that out there. So let's check this out.
So when it comes time to start adding animation to your game, there are really two primary ways to go about it. The first one, and probably the most commonly used, is sprite sheet animation. This is also the technique that most people recognize from traditional animated movies, because it simply means drawing a bunch of images, each with a tiny bit of movement, and then playing them back by quickly displaying them one by one. Our character from the previous video on 2D movement already has sprite sheet animation set up in exactly this way, so that's what we're going to be using for this video. But first, this video is sponsored by Skillshare. Skillshare is an online learning community with more and Alexander Blair for their support on Patreon. And I think we're now ready to start animating our character. However, there is another approach that I think you should at least be familiar with, and that is skeletal animation. As the name suggests, this animation technique works by binding bones to our sprites, which will then move and distort the images as we drag the bones around. The cool thing about this particular workflow is that it allows us to draw our character only once and then animate him fully inside of Unity. If you want to try out skeletal animation, Unity has a free asset on the asset store called Anima 2D that should help you get started. And definitely let us know if this is something that you would like to see a dedicated video on. Alright, enough talking, let's start animating. So we're here in the same scene as when we did our 2D movement. You can of course use any scene and character that you'd like. In this one we're able to move and jump around as well as crouch beneath platforms. But of course currently we have no animations in here. To change this, let's start by setting up some animation clips. To do this, we'll go to our scene view and select our player. We'll then open up our animation window. So we'll go under Window, Animation, and select Animation. And as you can see, it tells us that to begin animating the player, we need to create both an animator and an animation clip. We'll talk about the difference between the two in a sec. For now, let's just hit create. And now we can choose where we want to save our animation. Let's right click and create a separate folder for this. And let's call it animation. Let's then double click this folder. And let's also rename this animation file to something like player. And then underscore the animation that we want to work on. This could be run, jump, or die. In our case, let's start with an idle animation. In other words, the animation that the player plays when he isn't really doing anything. We can then press save. So now we have this empty timeline here where we can drag in our animation sprites. Of course, the great thing about our character here is that he already comes with a bunch of images that we can use. So let's go under Sunnyland. And of course, if you want to download any of this, I will have a link for that in the description. We then go under Artwork, Sprites, and under the player, we can see that the sprites are split up into animation folders. So let's start by going under the idle folder. And here are 4 different images. If we just try and select one of them, we can see a preview in the bottom right here. Of course, it's pretty tiny, but if I go ahead and move through the images, we can see that they are indeed animating our character. So let's try and select all 4 sprites, and let's simply click and drag them into our animation window. And right away, we can see that 4 keyframes has been added. We can also see that if I hit play, the animation plays ridiculously fast. The reason for this is that we need to change the amount of images that are displayed each second. Currently our samples are set to 60. A pretty standard value to use here is something like 12. We can see if we now play through, the animation looks much better. And we can even scrub through it using this timeline marker. And if we wanted to say move around a few images, we can of course do that by simply clicking and dragging, or just press delete in order to remove one. But I'm just gonna leave my animation as is. And let's go ahead and set up a few other ones while we're at it. So let's go to where it says player idle here, and let's hit create new clip. Again, we want to make sure we do this inside the animation folder. And this time, let's create one called player_run. Now let's go under our run folder. Let's select all of our sprites and drag them in. Again, we want to decrease our samples to 12. And if we now hit play, we can see our character is running. Let's quickly do this for the crouch animation as well. So player_crouch. We'll go under the crouch folder, select both of them and drag them in. Again, we'll set the samples to 12. Again, the animation plays fine. And finally, let's add our jump animation. Player_jump. We'll go into the jump folder, select both sprites, drag them in, change the samples to 12. And if we try and play this one, we'll notice that it looks kind of weird. The reason is that our jump animation is made up of only 2 keyframes. One for when we are going upwards and one for when we are falling back down. Now we could of course go in and create these as 2 different animations. However, I think that's just overcomplicating things. Instead, I'm just going to go in and change the samples to a much lower value like 2. I think this is going to change our sprite around the time when we're at the peak of our jump, but we'll see that later. So now we've set up all 4 animation clips. And if we go into the animation folder, we can see all of them here. Player idle, player crouch, run, and jump. And we can also see another file in here, simply called player, which has a different icon. This is what we call the animator controller. The animator controller is called a controller because it controls what animations to play. If we double click this, it's going to open up in our animator window. So here we notice that one of our windows is called animation. This is where we create our actual animations. And another one is called the animator because this is where we choose what animations we want to play. And in here we can also see that it's already added our 4 animation clips. We can now drag these around and arrange them in any way that we would like. And if for some reason one of them isn't in here for you, you can always take an animation clip from the project and simply drag it in. And you can of course also select and remove them. You'll notice here that currently the player idle is marked as orange, and it's connected with this arrow going from the green entry state. The reason for this is that the idle animation is currently our default animation. In other words, it's what will begin playing right when we start our game. So if we were to now hit play, we can see indeed our player starts playing the idle animation right away. And even though we move around and jump and try and crouch, it's just gonna keep playing idle. In fact, if we select our player and go under the animator, we can see the animation looping right here. So let's stop playing, and we can now start to create transitions from the idle animation to the other clips. By the way, if you want to set another animation as the default, we can always right click and hit set as layer default state. And that's simply going to change it. So whenever we start running, we of course want to change from the idle animation to our run animation. And we do this using what is called a transition. So if we take our player run here and just place it underneath our idle animation, we then right click on our idle and hit make transition. And we now get this arrow that we can drag out to the other animation clips. If we then click player run, we've created a transition from our idle to our run animation. And if we select this transition, we can change when and how we want it to occur. So the first thing that we need here is to add a condition, because we don't want our transition to just play right away. We only want it to play in the case that we're actually moving. But currently our animator has no idea whether our character is moving or not. To change this, we use something called a parameter. So if we go to the left here, we can see that we have two tabs, layers and parameters. We want to go under parameters and hit the plus sign, and here we can now create a new parameter. We're going to create a float, and this float is going to represent our player's speed. So we'll call it speed, and we'll just default it to 0. Then under our condition, we can now hit the plus sign to create a new condition on our transition. And here we can say that we only want to transition to our run animation if our speed is greater than, and it will just input some small number like 0.01. In other words, if we start moving, well then we want to transition to a run animation. We also want to go in here and make sure that this transition is immediate. In other words, we don't want something called exit time, where we wait for the animation to stop playing before we start playing a new one. No, we simply want to transition as soon as we start moving. So I'm simply going to disable that. Let's also go under settings, and here we can choose the duration of our transition. This is not something that you often use when creating 2D games, but it's used all the time to blend between animations in 3D games. But for us, again, we want this to be completely immediate, so we'll go in and set the transition duration to 0. Of course, we also want to be able to transition back from our run animation. Currently, we will only be able to go from our idle to run, and then even though we stop moving, it will still play our run animation. So we'll go in here and right click and make a new transition. This one is going to go to idle. Let's select our transition and add a new condition. This time we only want to transition if the speed is less than, and then we'll again add a tiny number here, so 0.01. Again, we don't want any exit time, and under settings we'll set the transition duration to 0. And now our animator should actually work with these two animations. In fact, if we take our animator and dog it to the right here, and then try to hit play, we can see that by default it plays the idle animation, but if I then go and change the speed, say set it to 1, our character starts running, and as soon as I set it back to 0, he goes right back to idling. So now all we need to do is change this speed parameter through our script, and that is actually fairly easy. So if we now select our player, and if you haven't watched the video where we set up player movement, we're basically using two scripts. One is the character controller that takes care of all the physics that go into making our character move. And the second one is a much simpler player movement script where we simply tell the player when to move and at what speed. So let's go ahead and open up this player movement script. And the first thing that we want is to be able to access our animator. Luckily, if we have a look in Unity, we can see that when we started creating animations for our player, Unity actually added an animator component to our player. And we don't need to do any adjustments in here, we can just see that the component is actually referencing the controller. And so that's why whenever we make a change to our animator controller, it applies to our player. So now we just need to be able to control our animator through our player movement script. And to do that, we need to reference it. So we'll go in here and create a public animator, and we'll just call it animator. And that's basically it. If we now save this and go into Unity, we can see that we have this empty animator field, and this is where we can drag in our animator component. So now every time we write animator in our script, we can access this component right here. And so if we go into the update function where we get our movement, we can actually go in here and write animator dot set float, and then we give it the name of the float that we want to set. Remember, this is the name of our parameter. So inside of our animator, we can see that the name of our parameter is speed. And notice that this has a capital S. So inside of our script, we can then write speed with a capital S like this, and then comma, and then we can give it the value that we want. In our case, we wanted to give it our current horizontal speed of our character, which is this horizontal move variable right here. So we'll simply write horizontal move and close it off with a semicolon. But there is a tiny mistake in here, and that is that our horizontal movement will be positive whenever we're going to the right, and it will actually be negative whenever we're moving to the left. And we want our speed variable to always be positive. So to change that, we can go in and use a handy little function called mathf.abs for absolute. So this is going to take the value and make sure that it's always positive. So if we now save this and go into Unity and hit play, we can see that as soon as we start moving, our character is going to play the run animation. And as soon as we stop, he goes right back to idling. Awesome. Now we want to be able to jump no matter what animation is currently playing. So whether we are idling or running, we always want to be able to jump off the ground. And so we could go in here and create a transition from each single clip to our jump animation. But as we add more clips, that would quickly become very tedious. So instead we can use this any state right here. And this basically allows us to create transitions from, well, any state. So no matter if we're idling or running, we can transition to our jump animation using this node here. So I'm just going to take this and drag it down and drag the entry up here to get it out of the way. And let's take our jump animation and drag it over here. And now we can transition from any state to jump. And of course, we still need to go in here and specify a condition. Otherwise, we're just going to be jumping all the time. And for this condition, we need a new parameter. So let's hit the plus sign. And this time we want it to be of type bool. Are we jumping or not? We'll call this isJumping. And we'll just set it to false by default. And then under the condition here, we can hit the plus sign. This time we don't want to check for speed. Instead, we want to check if isJumping is true. And again, if it is, we don't want any exit time. And we also want to set the transition duration to 0. Of course, we also want to be able to transition back from jumping. So let's go ahead and create a transition to the player idle here. And we only want this to play if we are currently not jumping. So isJumping is false. And our current speed is currently less than 0.01. And so this is really cool. We can add as many conditions to these transitions as we want. Let's also add one to play run. So we'll make another transition here. And this one we want to play in the case that, again, we are not jumping. So isJumping is false. And the speed is currently greater than 0.01. Again, we want to make sure to go through both these transitions and set has exit time to false and the transition duration to 0. And the same for the other one. And now our animator should be set up. Of course, we still need to make sure to control our isJumping parameter through our script. And if we go into our movement script, we can see that we currently get some input for whether or not we want to jump. And of course, we can go in here and set jumping to true. So we'll go animator.setBool this time because it's a Boolean parameter that we want to change. The parameter is isJumping. And here we want to set it to true. However, we actually don't have a way of knowing when we want to stop jumping, because all we're doing here is really giving our player controller input. There's no place in our code where we have anything about actually landing again. To get around this, I've gone ahead and added a bit of extra code to our character controller. If we select our player and open up the character controller, we can see that there's a section here called events. And in here, there's an on-land event. Events basically allows us to trigger certain functionality when something occurs. In this case, this event will be triggered whenever our character lands on the ground. And so we can use this to tell our player movement when to stop jumping. To do that, we need to go in and create a separate function for this. We'll create a void. We'll call it something like onLanding. We'll open and close some parentheses and the same with some curly brackets. And in here, all we want to do is tell our animator to stop jumping. So we'll go animator.setBool isJumping. And we'll set it to false. And this will work just fine, but in order for our event to be able to see this function, we need to mark it as public. And this might look a bit strange to you. Normally people associate public with variables, but we can actually make functions public as well. If we now save this and go into Unity, we can add a new onLand event. So we'll hit the plus sign here. And here we can feed in a component. So we want the player movement component. And then we can go and choose a particular function. We'll go under the player movement script. And in here we can now see our new on landing function. If we select that and then play the game, we should see that whenever we jump, it plays our jump animation, and as soon as we land, it transitions right back. Super cool. We can also see that for some reason it only plays the first frame of our jump animation, and the reason for that is that if we go into our animator and check the transition going to our jump and then go under settings, it's currently set to can transition to self. So what's currently happening is that whenever we're jumping, it's actually just transitioning to jump over and over and over again, and so it's stuck on the very first part of that animation. If we remove that, it will only transition to jump once and then play the jump animation, and then as soon as it's done, it will either go idling or running. So if we play the game with that change, we can see that our jump animation works perfectly. And the final thing that we want to go in here and add is the crouch animation. So let's drag this to the side up here. And first we want to be able to crouch from idling. So we'll add a transition to crouch here. Let's select it and let's add a condition. But first we need a new parameter. So we'll go in here and create a boolean called isCrouching. And of course we want the condition to be that if crouching is true, well then we want to start crouching. Again, we want to remove exit time and duration. And we'll also create a transition back. This is if we are not crouching, so if crouching is false, and our speed is currently less than 0.01. And remove exit time and the duration. And I'm actually getting a warning here, and this happens sometimes when you set the transition duration to 0. It's pretty annoying and it will kind of spam your console with this warning. It doesn't really do anything to the code, but I found a nice workaround, which is to set the exit time a bit larger just before disabling it. It won't do any difference whatsoever, but it will make sure that we don't get this warning. We'll then create a transition from the run animation. Of course, the demand here is that isCrouching is true. Again, we'll remove exit time and duration. And finally, we want to be able to transition back in the case that we are no longer crouching and our speed is greater than 0.01. And here I'll use my trick, so bump up the exit time, remove it, and set the duration to 0. And there we go. That is it for our animator controller. Finally, let's set our isCrouching parameter through our script. And if we have a look at our player movement here, we can see that we do indeed control our crouching through this. However, there is one slight problem with this, and that is in here we're only telling the character controller whether or not we want to crouch. However, sometimes our controller won't actually listen to our demands, because if our character decides to crouch under a platform and then chooses to stand up, he won't be able to because there's a ceiling above him. And so we of course don't want to play an animation where our character stands up. That's gonna look super weird. So just like jumping, we actually want our crouch animation to be controlled by our character controller. And of course, because of this, I've gone in and added an event for that as well. So if we go to our player and under the character controller 2D, we can see there's also an onCrouch event. And this is a tiny bit different from the onLand event in that it's actually a Boolean event, which means that not only will this trigger a function when we start crouching, it's also going to trigger the same function when we stop crouching. And it's going to tell the function whether or not we started or stopped crouching using a Boolean. So to show you how this works, let's go into our player movement and let's create another function under our onLanding. Again, this is going to be a public void and we'll call it onCrouching. And this time we're going to take in a Boolean variable as an argument. We'll call this something like isCrouching. We'll also open and close some curly brackets. And now this variable here is actually going to be controlled by our character controller. So that if we are crouching, this is going to be true. And if we're not, it's going to be false. So we can simply go ahead and set our bool on the animator. So animator.setBool. And we want to set the isCrouching parameter. We can set that depending on our isCrouching variable right here. So we'll simply pass that in directly. And now if we save that, go into Unity and add a new onCrouch event. Again, we want to drag in our player movement. We want to go under our player movement script here, and we can see our onCrouching function. However, we can also see our onCrouching function at the top here under dynamic bool. And that's because if we select this one at the top, it's going to automatically pass in the right boolean. So let's select that. And let's take our animator and dock it to the bottom here so we can see everything happening while we are playing. We then hit play, and now when we crouch, we can see that we transition to the crouch animation. And we can also crouch under this obstacle, and if we try and stand up, it's not gonna work. So now we can jump and run around, we can idle and we can crouch, and everything is going to work just fine. It's always going to play the correct animation. Super cool. That's pretty much it for this video. If you enjoyed it, make sure to subscribe
Okay, so a couple of quick things to wrap up before we go on break and then come back and start working on stuff. Um, in Is anybody in here in mobile app this semester? No, Brandon I know is, but I didn't know if anybody else was. So in mobile app, we begin the semester talking about Cordova, which is a program that is a framework that allows us to use HTML, CSS, and JavaScript to make mobile apps. We also talk about doing so with Xamarin, which is Microsoft's like Visual Studio version of a mobile app builder. It allows us to build mobile apps for Android and also for iOS using C# as our code base. The third thing that we learn about is how to make mobile apps using Unity. Now, the class gets to choose which of those three routes they want to take. Most people pick Cordova just because there's no reason to. I always describe like using Unity or Xamarin to make a mobile app in most cases, similar to if you used a bulldozer to build a sandcastle, right? That we're going to take all this extra. We have all this extra power we don't really need. Like the app that they're doing this semester is kind of like it's a restaurant suggester based on criteria, but you can also get. So basically, it will give you a restaurant. You pick type of restaurant, type of food, distance from you, and how much it's going to cost, and it picks random restaurants based on that criteria. You can do all that in JavaScript very easily, and CSS and HTML. So they're going with Cordova. But we're still going to learn about the other stuff, but they're going with Cordova. I say all this to say that I want to make sure that the skills that I am giving you are preparing you for the workplace, right? And unless you're going in to work for a game studio, you're not going to be making games, right? You might be if you're fortunate, but you still might be making mobile apps, right? Or other forms of interactive applications that Unity could do a lot of that heavy lifting for you, right? You still have the C# skills, but you're letting, it's just another framework that you're using, right? So I want you to be thinking over the next semester or two about how you could use Unity to do things other than games. Because when we get to software engineering project, maybe you want to use Unity to make some sort of, what if you want to do a virtual reality tour of the campus, right? That's something you could do in Unity. That's absolutely a valid software engineering project, right? You could do some sort of virtual interactive tour where people can put a headset on and walk around and do stuff and learn about the campus, and that way that we could give tours to people. I mean, but we wouldn't have to get into big crowds, right? In case we have to be quarantined or have social distancing and things like that, right? All right, cool. Any questions, concerns, comments, thoughts, ideas? Perfect. Come back at 10:15 and we will start working on